So, next section, we are talking about the precise definition of a limit. So,
I don't get it.
We just paused the recording
For
and everybody's
something
crying. This.
okay, so motivation. Let me ask a question. If I gave you a function, okay, so the function is f of x equals 2x minus 1 if x is not equal 3, and 6 when x does equal 3. So, you know, you could draw a piecewise function. When x is 3, you get out 6. And if I plug a 3 in this, I get 1, so that would be an open circle. That does not look open. We have a line with a y-intercept of -1, slope of 2. So we can plug in, I don't know why I put my point down here. I did x minus 1 instead of 2x minus 1. So if I plug a 3 in here, that would be an open circle. 6 minus 1 is 5. We'd have an open circle up here. So my graph looks like a line that has an open circle on it and then a separate point on the graph. Okay?
You better not go to the movies this week.
So, we know if you are getting close to 3, what y value are you approaching? 5. Okay. So, if I wanted to be within a tenth of 5, so I wanted to be somewhere between 4.9 and 5.1, could you figure out how close to 3x would have to be to make that happen? Probably. I mean, do we want to? Probably not. But if I said, okay, you've got to be, I want your y to fall somewhere between here, because I need to be that precise. Could you find the corresponding x down here and say, okay, then you have to pick some x in that window to make your y fall in this window. Okay. And if I wanted to be even more precise, what would I have to do? Make my window bigger or smaller? Smaller. And the more accurate you want to be, the closer to 3 you would have to get. Does that seem reasonable to everybody?
Yeah.
Okay. So the true definition of a limit says this limit equals 5 as long as you can get more precise by making your x get closer to 3. So if I want you to be within a tenth, you could find an x that would match that. If I said, nope, a tenth isn't accurate enough, we need to be within a hundredth of 5, you could get me an x that would get me there. Or if I said, nope, we've got to be more accurate, I want to be within 1,000, you could find the x that matches that. Does that seem reasonable? Okay. You know, if you think about like construction, this kind of happens. You need a certain length of a board. Every time you cut that board, are you going to be exact with that measurement? Probably not. We're human. Are we perfect? Even if you have a machine making something, is every single piece completely identical? No, there's a margin of error. And we know that in order for this board to work, it has to be this close to the real length. And if it's further than that, it's not going to work at all. So we have to make sure our machine is calibrated a certain way to guarantee that my end result falls within the acceptable window. Okay, does that make sense? So that's kind of what the precise definition of a limit is. So, the distance between x and 3, that's the absolute value of x minus 3. Distance is always positive, right? So we put the absolute value there. And the idea is you can make your y, so the distance between your function and 5, as close as you want just by making your x get closer to 3. So we start seeing these weird looking variables here. These are just Greek letters, they just mean a variable. And we're going to start seeing something called Epsilon and Delta. So this is a delta. Basically, if the distance between the x and 3 is smaller than a certain number, we'll guarantee that the distance between my y and my 5 will be smaller than a certain number. So, we could actually work backwards and figure out how close we need to be. Let's say I wanted my y to be within a tenth of this number. So, the distance between my function and y is less than a tenth. We're going to figure out delta. How close to 3 do we need to get to make that happen? And so, this is kind of our process. We really don't need this 0 here. Why?
Because absolute value can't be.
Yeah, absolute value is already positive, right? So your book sometimes has 0 is less than this, is less than delta. That 0 is really not necessary because we know the absolute value is already positive. So, let's start with here, my function. So my function, that line, its equation was 2x minus 1, right? So if I plug that in for my f of x, I replace my f of x with 2x minus 1. Then you could combine like terms, -1, -5 is -6. 2x minus 6, what could you take out of that? 2. Since 2 is positive, you could bring it all out in front of your absolute value. And we then see this absolute value of x minus 3, which is my delta. So my original statement is basically the absolute value of f of x minus 5. We said we wanted that to be within 1/10, right? And so we've turned this into the 2x minus 1 minus 5. So if I factor out my 2, if I divide my 2 over, that means the absolute value of x minus 3 is less than 0.5. So, grab a calculator for me. What we have just decided is that if my x is within 0.5 of 3, then my y should be within 1/10 of 5. So pick a number within 0.5 of 3. So that means you need to pick something bigger than 2.5 but smaller than 3.5. So what number should we try?
3.2.
3.2. We'll try 2.7 next. So if I plug a 3.2 into this, so 2 times 3.2 minus 1.
Should it be 0.05?
Yes, thank you. I dropped a decimal, didn't I? How about that? So if we're trying to be within 500ths, so we need to pick something between 2.95 and 3.05. So how about 3.02? So plug in a 3.02. Do we get something that is within 1/10 of 5? So meaning something between 4.9 and 5.1.
Yeah.
Yes. If we plug in 2.97, do we get something that is within 1/10 of 5? Yes. So if this limit is in fact 5, I should be able to change these numbers. I should be able to go back and say, you know what? 1/10 isn't accurate enough. If I wanted to make this 0.01, could you find the new x value that we needed? Yeah. And so that's what the precise definition of a limit is. We have to find these magical numbers so that I can just say, okay, I need to be this accurate, and then you can turn around and tell me what x has to be. That's what we're going for here. Okay, so here is the formal definition of a limit. Limit as x approaches a of f of x equals L if for every epsilon greater than 0, there is a delta greater than 0, such that, and I told you we don't really need this, if the absolute value of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon. F of x is my function, L is the limit, epsilon and delta are these magical numbers that we are going to find. I'm trying to give you guys lots of visuals of what we're looking at here. So what the definition says, the limit is like the middle. If you are less than epsilon or bigger than epsilon around it, then we should be able to find an interval for my x's that guarantees it will work. So if I want to land over here, you should be able to pick an x within this range. If we look, okay, so this one, my epsilon, okay, that's measured by this orange. So if I want to fall within the orange mark, I would have to make my blue get more narrow, right? So if I want to guarantee my y falls in that, then I have to take my blue area and squeeze it in to guarantee. So I would have to pick something in that blue window in order to guarantee that my y fell within the orange window. And these are just more pictures that just are trying to explain what's happening here. So the limit we know is the y value we're approaching. Epsilon is how far away from that limit you can be. And so if I want to fall within this blue range, I have to figure out what x's would get me there. So that distance from x is your delta. All right, let's look at an actual example now. Let's see if we can take a graph. We're not going to actually use a graph to do these, but I kind of want to use that visual for a little bit to understand what's going on. The definition of a limit says if the absolute value of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon. Okay, so from this statement, what is my function?
X cubed minus 5x plus 6.
Mm-hmm. What is my limit? 2. Okay, so what this means is we need the y to fall between, this is saying we're within 2/10 of 2. So what values would that be? Would you could be 2/10 above or below? Mm-hmm. Let's grab a graphing calculator. I want to graph my function. X cubed minus 5x plus 6. Okay, if you just look look at that, we get our normal function. Now, specifically, we are wanting to know when our y's will fall between 1.8 and 2.2. So, to kind of narrow that down on our calculator, we could graph those lines. So I'm going to set a line at 1.8, and I'm going to set a line at 2.2. Here's my 1.8. There's my 2.2. Am I really seeing a lot here? No, so we might need to adjust our window. It looks like they're intersecting over on the positive side, so maybe my x min will be 0. Maybe I make my x max 5. Y's, let's just go from 0 to, we can go 0 to 5, see if we get what we need. So there's my graph. There's 1.8. And there's 2.2. And I am worried when x is close to which value? If you look at this original statement, I want x to be close to 1. The formula has the minus index, might say. So I want to know how close to 1 do we have to be so that my y falls between these values. So we know it hits my graph twice, but when x is 1, it's here. So we're looking at these. Okay, so if we go into our calculator, we can go to second, trace, and let's find an intersect. First curve, it's on my on my cubic, so just hit enter. I'm going to do the black line first. And guess. So I just want to be close to this point. So that is 0.9114. We want to find that other value. You go to second, trace, intersect. First curve is the blue one here. Second curve I want to be my red line. Guess just close to the point, and that is 1.124. So what that said is if I pick any value between these two numbers and plug it in for x, you should get a y value that's somewhere between 1.8 and 2.2. Let's check it and see if it works. If I put in, how about 9 or 0.95? I get 2.107. So is that in the window of values we wanted? Yeah. We said it had to be between 1.8 and 2.2. If I plug that in, I get 2.1. And any number you pick in this window will get your y close enough. All right. I know it's not clear yet, and that's okay. Do you guys kind of understand what we're going for? If we want our y's to fall within a certain window, our x's have to be within a certain range. Okay. So a math proof is very generic. You don't want numbers. You're trying to give a justification for something that would work regardless of what numbers we pick. And so we are going to start using what's called the Epsilon Delta definition. And I'm going to just go ahead and skip to this. So, there's a very precise way to do a mathematical proof. You can't leave any gaps. You have to start with your assumed statements, you do your work, and you make a conclusion. at the end. So if epsilon is greater than 0, because we have to have, we're just talking about epsilon, remember, is your distance from y. Distance is always positive. Then we'll start with f of x minus L is less than epsilon, kind of like we did here. And we're going to work that out to figure out how close x has to be. So that's kind of like our scratch work. We're doing that on our own beforehand. Then we will actually do the proof of this statement. So we are going to go through a lot of these, not just today. We're going to do more Monday. But I want to walk through the entire process together. So if I wanted to actually prove this, first of all, does everybody believe that this limit would be equal to 7? Yeah, it's a polynomial. We know we should be able to plug it in. So it gives us 7. So the proof, we have to think back the actual definition of a limit. We are going to prove this statement. So, our goal, and I write this out every time just to try to show you guys what we're doing, is the proof. So the definition says, if the absolute value of x minus a, what is my a value here? 3. A is what x is approaching. So if the absolute value of x minus 3 is less than delta, then the absolute value of f of x is my function. What's my function here? Minus L, what's my limit? Is less than epsilon. So this is just straight from the definition. Definition is if the absolute value of x minus a is less than delta, then the absolute value of f of x minus L is less than epsilon. So I just plug in my f of x, my a, my L. All right, is everybody writing this out with me? Working through it? Huh? So, that's our goal. It's what we have to accomplish. Step 1, we have to find the delta. Oops, find delta. And so we're actually going to work backwards here. I'm going to look at this statement. So the absolute value of 4x minus 5 minus 7 is less than epsilon. I'm going to start there. All right, what can I do on this inside? So that's 4x minus 12. Then what can you do? Take out a 4. Since it's a positive, I could go ahead and bring it all the way out in front. I'm trying to get this back, x minus 3. You notice this is very, very close to it. So what should I do? Divide by 4. Okay, so here's our scratch work. This tells me, essentially, if I told you how close I want your y to be to 7, you should quickly be able to tell me how close x has to be to 3. If I said I wanted it to be within 1 unit of 7, so I want something between 6 and 8, then what would your x have to be? If I want y to be between 6 and 8, x would have to be epsilon over 4. So my epsilon was 1, so x would have to be within 1/4 of 3. So it would have to be between 2.75 and 3.25. We're finding a formula to do that. So if I said I want to be within a half of 7, then you could come down here and say, okay, well, 1/2 divided by 4, I'm going to be within 1/8 of 3. And so I could give you any y value, and you could turn around and divide that by 4, and that's how close x has to be. So this is our scratch work. Now we know how close x has to be. The second step is the actual proof. So we have our goal. That's just a statement to kind of help us. That's our scratch work. Now this is the actual math proof. And it's going to be the same every time. You are going to start out, the if is like you're given. So we are going to start out writing all of this stuff. And we are going to have to prove that it is less than epsilon. So I'm going to write that green line again. If, oh, but I should add in first. I'm going to go ahead and do this first. Let delta equal epsilon over 4. That's what we just found up here, that my x had to be within epsilon over 4. Then I'm going to write out my definition. If the absolute value of x minus 3 is less than delta, then the absolute value of 4x minus 5 minus 7, and then I have to work this out until I get the less than and the delta. We're really going to be repeating the same stuff that we had done above. So we combine like terms. We can factor out the 4. But I know now, I said that the absolute value of x minus 3 is less than delta. So this statement would have to be less than 4 delta. Okay, so you notice right now, I got my less than what that I needed. All that's left of my definition, we now have the less than, we have to get epsilon, right? In my proof, the very first statement, I said delta is equal to what? So this is 4 times epsilon over 4, which is epsilon. And I got my less than epsilon, so I am done. That is your first real, serious, actual math proof. Okay, I know it is extremely abstract. Okay. And I know it seems pretty pointless because we already know how to evaluate these limits. But in higher levels of math, a lot of it is just proving things are true. You know, if you look at the work of early mathematicians, they didn't just say, this is always going to be the case. They proved it. That's how things come to be believed, if you have solid proof. So that's what this is. Now, like I've already told you, this is hard. So it's not something that I'm really going to assess heavily. We're going to do homework. We might have a quiz question. On the test, it would probably be a bonus question. But once we start doing these, you'll realize they're not as bad as they seem. It's kind of the same thing over and over again. So if we can get in the habit, we'll be okay. The main thing, we have to know what the definition is. So you have to know this statement. And then every time we're just going to be plugging things in and our layout will be the same. So let's do one more together. I'm not going to give you any homework tonight, but we're going to do one more together and that will be where we end today. Alright, so you have to know the definition. And I always write that out first, so I know when I'm done. My goal, the definition is if the absolute value of x minus a is less than delta. What is my a?
3.
So if x minus 3 is less than delta, then the absolute value of f of x minus L. What is my f of x?
13.
Minus, what is my L?
10.
Is less than epsilon. Does everyone know how I got this?
Oh,
What?
I wrote the last problem on the wrong board.
Uh-oh. I did skip a slide in there,
So
so
I just drew an arrow.
that was kind of my fault. I skipped one on the calculator and we disproved it. Okay. That's what I want to do. So step 1 is my work. We have to find our delta. We have to figure out what works. So we're going to start with this conclusion statement. So the absolute value of the 13x minus 29 minus 10 is less than epsilon. What are you going to do with that? So you get 13x minus 39 is less than epsilon. Then what are you going to do?
13.
And then what do we do? Okay. That's our work. What we just found there. We said the absolute value of x minus 3 has to be less than delta. We got that the absolute value of x minus 3 is less than epsilon over 13. So step 2 is the proof. You have to first tell me what delta equals. That's what we just found. What is my delta? What did we just find? Then we go to our definition. And we're going to write all of this, and then we have to work it out until we get the less than and the epsilon. And at this point, you're really just redoing the same work we already did when we were finding delta. We have to restate it because this is the actual proof now, so we can't just say see above. We actually have to work it out. Okay, but then what do I know? I get this absolute value of x plus 3, 13 absolute value of x plus 3, but the absolute value of x plus 3 is less than delta. So this is less than 13 delta. And what is delta? So that's 13 times epsilon over 13, which is epsilon. I told you we had to get the less than and the epsilon, and we did. So we're done. I know we're not there yet. What